DoneJS contributors meeting. Today is Friday, December 8th, 2017. My name is Chasen Lahara, coming to you from Long Beach, California. And today we've got people all across the globe. You guys want to introduce yourselves?
Yeah, my name is Julian. I'm from Germany. So nice to meet you again.
Good to see you.
Hey, I'm Justin from Chicago. Never meet your heroes. My daughter's freaking out because she's met a YouTube musician who she watches baby videos of.
Hey, I'm Kevin from Westmont, Illinois, and I am waiting for my cold medicine to kick in.
Hope it does.
Now.
Hey, I'm Manuel. I'm from Yaritagua, Venezuela, but I'm currently living in Denver.
Good to see you.
Hey, I'm Matthew. I'm from Kentucky, and as I was talking to Kevin, I dislike green tea.
It's a shame that you think it tastes like what? How did you describe it? Butter mud?
Bitter mud.
Bitter. Butter mud would be okay,
Yeah.
but bitter mud, yeah. Anyway, okay, so what we're going to do is we're going to go through demos and talk a little bit about status and what we've been working on as part of our demos. And then afterwards, if there are any topics to discuss, we'll go to those. I'll get us started. Let me share my screen. So the past couple of weeks, I've been helping with, basically everyone's been helping with the efforts to get get CanJS 4 out the door. So as part of that, we've been publishing pre-releases. This is the main can package. So you can see we're kind of publishing like 4.0, pre-5, pre-6, etc. So if you're using just the can package, you can install those. And then if you're hopefully using all of the individual packages like can component, can stash, what have you, those also all have pre-releases that are named the exact same way. So those are available for install. I want to point out on canjs.com, we've always had this little drop-down that lets you switch between the CanJS 3 site and then go to the old CanJS 2 site. We also added this for pre-X. If you click on that, this goes to the site that we're using to put together all of the CanJS 4 docs. You'll see it's very similar to the CanJS 3 website. Kind of the big things are that, kind of to take a step back, in CanJS 4, we've talked about some of the big changes in debugging and adding can queues. And in our efforts to get a CanJS 4.0 release out the door, we're focusing on the core and infrastructure packages, and then we have a few of the legacy packages. Can map, can list, and can compute is now in legacy. We don't plan to have all of the ecosystem packages in the initial 4.0 release. I think can fixture, I don't know if there are any other ecosystem packages that we're going to have. So we've updated, we're in the process of updating the site to have all of the new 4.0 goodness. So I know Matthew and James, I'm stealing a little bit of thunder from them and saying that we've been updating the recipes so that they use, so that they're all updated for CanJS 4. And then also under docs, we have all of the packages that are included in CanJS 4, which is, you know, a little bit slimmer from what we had in CanJS 3.
You'll notice can observe is the other ecosystem.
Oh, can observe isn't. I didn't realize that it was in. I forgot that we had decided to put it in ecosystem. So yeah, can observe is listed here too. I do not have a demo of using can observe. Hopefully, we'll be able to demo that maybe next time with the main can package. So updated site, we are in the process of updating things. Like we don't have, like if you're interested in being on the bleeding edge and using the pre-releases, we don't have a migration guide. We've started to put together our notes, but kind of next steps are for us to finish updating the sample code and demos that are on the site, and then do things like migration guide and the little details that'll make it easier to upgrade. I think that's it for me for what I wanted to talk about, unless someone had any questions or comments.
Just comment-wise, since I did work on several of those recipes and stuff, the migration is very easy. So if anyone's like concerned, there's not really much. I think most of it is in the template, I believe. Like getting the biggest thing that's probably might take some time to figure out is there's not any automatic scope lookup, which means that if you're, especially like inside of like an each loop or something, and you want to call a method on the view model, you got to make sure to do .. /view model method or whatever. That's where most of the things that I found were there. The other thing is there's no more all those percentage sign event and all those types of things have changed names. So, but most of the stuff is contained within the templates, I think.
Yeah.
I was going to say something about that. Do you think we should show root dot, or do you think we should show .. or should we? Part of me is almost.
Is there a root .. Is there's a root thing?
Scope dot
root.
So that's the view models. View model. That's the
components. Yeah.
Okay. I didn't know.
I'm not saying that we necessarily should show that versus .. / I don't know.
I think
I'm throwing that out there.
I kind of like that just because when I was doing it, a lot of times I was like, it's hard, it's hard to look at it. Yeah, it's hard to tell. Like, it's hard to look at a template and know how many.
Yeah,
how many scopes there are.
I mean, that's why, like, when we originally proposed this, I thought we'd have a discussion about, like, I was in favor of having 2 keywords, and there was root or view model and scope, because I feel like talking to your view model or your root is just so insanely common.
Yeah.
I wouldn't. I mean, I don't know how. I forgot. I feel like we got pushback. I got pushback from that as an idea. I wonder if people feel like maybe it's a good idea to have.
It is definitely very common to call the view model. The biggest problem I found was like inside of an each. You definitely have to go at least 1 level up, and then sometimes you have to go a couple levels up. So it's gonna be hard to tell.
Did you get warnings for all those things in 3.0?
For what things?
For all of those, like this thing wasn't found in your scope, so it's walking up. That's not going to happen anymore. Should be warnings for those.
I don't know. Maybe.
I wanted to interject that. Yeah, we do have warnings for when it's doing the implicit scope walking, and you need to specify it. Like percentage sign event or what have you. There's warnings for those. Yeah. So, like, step 1 in the CanJS 4 migration guide, it will be like upgrade to CanJS 3 latest, because it has really, really good warnings to get you to update your code before attempting a 4.0 migration. So yeah, I found those super helpful.
I know there are warnings. I just meant, were all of the things that you had to fix caught by those warnings? So, but
to be honest, I ignore the scope warnings because there's so many false positives that I assume that there's false positives.
Okay.
Yeah, that's a 4.0.
No, it's not a bug. Let me be clear. I'm not saying there are bugs in it. I'm just saying that the nature of it is that it throws warnings when stuff is not defined yet, but is going to be defined in the future and stuff like that.
But if you're transitioning to 4.0, I don't think any of those warnings are false positives anymore.
No.
If you're using can define and upgrading,
what if you? Like the common case I would have is like you have an async getter. It doesn't return anything. It's only going to resolve once the.
But there's a property there. Like in 4.0, we should at some point. I don't know if we've done it. Kevin and I have talked about this. We should be able to. What?
We haven't added that yet. Okay,
we should add that, which is if there's a property definition there, even if it's undefined, then we won't throw a warning. So we shouldn't be. We really. I mean, this would be a good thing to do right after. We can do it as part of the 4.0. So maybe you're right, there are some false positives, but then we should get rid of that last lingering one, which is like you have an undefined property value, but you have a property. Because then in 4.0, any warning like that actually...
You should know all properties. Yeah, there's no...
Also, in the migration guide, we should say, we should explicitly give, like, these are the warnings of things that we've removed in 4.0. Because like that one that you're talking about, a property that's not defined but then becomes defined, we're not changing that in 4.0. That's not a 4.0 breaking change. But the other warnings are. So we should make those clear in the migration guide.
Yeah, is a warning a breaking change?
Yeah, it's hard. I mean, we could...
No, I mean, there are other warnings that we've made breaking changes. Like that, we're not going to walk up the scope anymore. There's a warning for that in 3.0, and in 4.0, we've removed that behavior.
Oh, just,
I get what you're saying.
Just to be clear, with can observe, a property might not exist until a later date.
Can observe is different. Yeah, you're 100% right on that.
So I think we should just never care about whether it's undefined or not, right? Because if you're pointing at something that should exist.
I mean, we could have does what you found support enumerable? We can check if it's sealed or not, and then throw the warning. If it's sealed, then we should still give the warning. Because then you can't add properties, right? So you're looking at a property. Because the whole point is like people, I mean, the reason for this warning is people spell stuff wrong constantly, right? And in Stash, it can be tricky to like, you know, why isn't it working? Why, you know, hopefully with the can debug stuff and things like that, they can get a little bit easier, but that's still not like baked into like, you know, eventually what we need is like, you can click on that element and be like, what does it derive from? And then you would see like, it's from full name with only one L. You're like, okay, well that's why, right? But until then, like the warning is, I think it's still, especially with can define use, if an object's sealed, it's still very useful to just say, hey, you read full name with one L, that doesn't exist. So
another idea, and maybe I'm opening a can of worms, I'm bringing this up, but maybe like a can stash 5 is like everything has to be explicitly named. Like there's no, you can never just say foo. You always have to say root.foo, or if you're inside of a loop, you have to name your thing.
Yes, this was that other stash that I proposed, was it had naming for everything. I think that would be amazing. That would be great. Actually, I would love it if Stash's, instead of root, Stash's root thing was view model. So you're just writing view model. Yes, you're writing view model 100 million times, but like it's named, and then every time you, now this no longer mustache, but then at this point it's like, let's just make our own version of JSX or something, because I think that's like has other advantages. So I think that's kind of like the weird, that's like the thing we chose to do is like, okay, we're going to make a stash that's improved, that's upgradable. We've done that, but then I think the next phase will be like, we're just going to completely reimagine how, you know, templates in CanJS should work and look. And just start from scratch. Don't try to like, because people aren't going to be, anything that we go to, like what you're talking about, Matthew, then it's like if people are having to rewrite their whole application anyways, might as well just use a whole different template, you know.
I don't know if it necessarily be rewriting. You just have to add names inside of loops and
maybe
that kind of thing.
Yeah, maybe. I mean, sure. If you can come up with something that's like,
you can do that today, right? I mean, you could have explicit names for everything today in 4.0. That's kind of the point.
Except for the model.
Scope.root is the model.
Oh, there is a scope.root. Okay.
Yeah.
There is scope.root. I just, the reason why I kind of want to call it view models because it's almost always the view model.
It's so long though. It's so long.
What if it was just view model?
Yeah, it's close, I guess.
Then we just make view model a reserved property, which, I mean, to me doesn't feel like that bad. Root, I can understand not wanting root to be a reserved property, but view model feels like, who's writing view model anyways? Like, that's weird.
Because it's so long, nobody wants to write it. No, I'm giving you a hard time.
Well, I just gave you an eye roll back. Whoa.
But back to Matthew's original question, scope.root would be faster than doing .. // because scope.root is it uses one of those lazy properties we talked about before, so it doesn't actually have to look it up after the first time.
I think what I'm going to do in the demos that I'm updating is whenever it gets into like a .. / I might just use scope.root and just make that explicit.
Yeah, as long as it is your root. If you're doing like a loop inside a loop, then you still might need to do .. But
sure, but at that point, I'd have stuff named or whatever. I'm trying to make that explicit too.
Does anybody just want to do view model though? Am I alone in that? Just saying like, let's just add view model as a reserved word and stash and just like get rid of everything else, like view model and scope, and that's it.
I think scope.root is fine. But...
So you're saying view model is the root?
Huh?
View model is the root, you're saying?
Yeah.
So like if you're using stash without components, it's still going to be view model.
It is the model that controls the view.
Yeah. Okay.
I don't know, and it just lines up. If we want to like have this simplified mode and people understand it, like they label everything view model right now. Maybe can element, maybe it forces us to have can element to be, have view model there instead of data. I guess you have to think about that. Let's not decide this right now, I guess. Let's decide it like in a few days, maybe before we release 4.0. But if we're upgrading a bunch of things and it's like we're doing .. and I've noticed that
I think there's a problem.
It's annoying. I think scope.root is a solution. It's a long solution. I think just view model is a better solution.
All right, I'm sorry, we're still doing demos.
Yeah, let's move on. So Justin, do you want to go next?
I do. So what I want to do is, so hopefully everybody here is already subscribed to CanJS's YouTube channel and subscribe to DoneJS, like and subscribe. I did a presentation at DoneJS Chicago, and I've been trying to present, I've done a few presentations on how the new can key trees, can queues, and can observation works. And I put all of that together into a presentation that I'm hopefully going to make a video on that essentially shows building up CanJS's observable stack from the bottom up. My favorite part of this presentation is the last couple slides that I would like to show now real quick. Because it kind of puts everything together. If I can somehow show it and to the screen that is being shared. This time.
Perfect.
Oh, now it should be perfect.
Yep.
Okay. You see notifying deriving .UI mutating?
Yep.
Yeah.
All right. So what I'm going to go through is how all of this works real quick, or just kind of like the order that CanJS does things with queues and with trees. So at the top, I'm creating a simple map. Simple map is just like the can map of your, except it's even more simple. And it's just this, like, if we want to map a fast map type, we just use simple map. You have to use get and set to set its properties. I can listen on the first property of simple map, and it calls this function back. This function is going to be registered in the mutate queue, as we'll see in a little bit. And then I'm creating an observation that gets me's first and last, and then I bind to that observation. And then if I change first, I want to see that the top binding, the me.first binding, if I look at, first will be Ramya, and then the full name, if I call full name at that point, even though it's registered first, will be the fully updated value, and then later we'll get the full name on new value, or the full name on binding callback will be called getting Ramya Meyer. So this is what we want to do. Let's talk about what CanJS is setting up. So whenever you set up a binding, CanJS on me will keep a list of handlers organized in a tree structure. So it'll keep all the first bindings. It'll then organize handlers by what queue they belong in. So it's this first handler, this function, it's actually just going to put that in inside whatever that mutate object is actually an array, and it's going to have an array of all the mutate handlers. Then full name on is going to be bound. And what that's going to do is observations, which are like computes. They also organize their handlers by queue, but they don't have different properties they need to organize by. Instead, they just say all of the handlers for mutate or all of the handlers for different queues. So in this case, that function, that callback function is just going to be stored under mutate. So previously, I showed people like how the code works for all of these things as we built it up. What happens is when a observation is bound, essentially it runs the function that's passed to the observation. In this case, that's that full name function that's combining first and last. It runs that function between this observation recorder and stop that will capture all of the dependencies and then loop through all of the observables that it read and the events that we need to listen to on those observables. And then you'll notice it binds to that observable on the notify queue. So essentially what it's going to do is we're going to call that function. We're going to see that both me first and me last were read. And we are going to then bind on those events on that object and listen to its dependency, and then call this dependency change method on our observation in the notify. So in the end, all that's really doing is registering event handlers on the notify queue for first, a event handler to call on dependency change of the observation, and then another one on last to call in the notify queue on dependency change of the observation, of the full name observation, whenever last changes. So essentially, this is all we're setting up is this tree of handlers. And then when me changes, when me set happens, the following takes place. When a set happens, it's going to enqueue its handlers for that key. So in this case, we're changing first, and it's going to enqueue the first mutate and first notify handlers in their respective queues. So what's going to happen is on dependency change, full name's dependency change is going to be registered to be run in the notify queue. And then the first callback registered by the user is going to be put in the mutate queue. Then the queue is going to start running whatever tasks were registered. So in this case, it's going to call on dependency change. On dependency change is going to, I talk about this in the presentation, but you want to make sure that you're updating your values after all of the mutate queue has fired. So in this case, the dependency change of full name is just going to say, hey, call my update in the call my update in the derived queue. So it's just now we're going to call the update of full name observations update in the derived queue. Okay, then the queue is like, okay, well, now I'm going to run the next task, which just is the update in this small example. And what that's going to do is essentially rerun the function and check its value, see if its value has changed. And if it has, it's going to queue all handlers on full name. In this case, there's that FN on the mutate. It's going to stick that there. And then finally, what's going to happen is the mutate queue is going to be run. It's going to see there's this FRST function that was enqueued, and it's going to run this function, which is this function, and it's going to run. And because all of the handlers that users register are running the mutate queue, this is now running after full name has fully been able to update its value. And so we'll get full name get is Ramya Meyer instead of Justin Meyer is if the full name hadn't been able to update. And then it runs that task, and the other function is registered in the mutate queue, and then it'll run that task, which is that function right there, the full name on handler, runs that one, and then it's done. So that is how the trees and queues combine to make observations. And really the magic of CanJS is in some ways that whenever a user handler fires, so whenever like a user handler is run like this, you can read any other value or the DOM, and it should be fully up to date with whatever changes led to your function being called. Like CanJS essentially fully updates itself and everything internal before you get access to it, and queues are what supply that.
I have a question. Can you show that code again? Okay, so I think I understand what you're saying. You're saying that when first is set, before that that first handler gets called, the full name is already updated.
Yes.
Right?
Yes,
okay.
Because that happens in the
derive queue.
In the derive queue. So essentially, when anything is notified, it says, okay, if it needs to update its value, it essentially then says, okay, well, I've been notified. Great. I'm going to enter a new task in the derive queue for when I want to be up to date. Update, and then when it updates its value, and then dispatches all of its event handlers if it has changed. Which there could be other things listening to full name on derive or notify, right? Like there's other there's other observations that depend on full name, and then their handlers would be inserted and queued into the notify queue. And then essentially the queuing system always works that like if something's entered in notify, essentially we stop doing derives and we restart the notify queue until it's complete. Then we go to derive. Essentially, if there's a task in a queue before you, then those always run before they eventually get to mutate.
So is it true that in some previous versions of CanJS, full name would not have updated until you called get within that that first handler?
It wouldn't have in some versions of CanJS. Well, I don't know if in this simple example, I think
just nothing's binding to full name.
Yeah, we
bound.
Oh,
okay, you are binded to it. Okay.
Yeah.
Okay. So I guess the magic of queues is now that, because there's, I guess in the past there's like really just one queue. Because of that, it was kind of a first come, first serve, right? Is that?
Yeah, there was still two queues in the other system. In some ways, there was like a notifying and a deriving queue, but like the user queues, it was just really.
They're all jumbled together, right?
It was all jumbled together where the ordering here could like kind of go back and forth, really, really in weird, strange ways. And now it's just like I don't know, Kevin, if you've worked in this too much yet, but it's a million times easier to understand, at least for me, who has to maintain it. And I know Kevin's done a little bit of it too. To me, it's really easy now. Like if I want to build something like an observation, like I know where that needs to update itself, right? I know if I'm like, and I know what I need to bind, where I need to run to get my notifications. If I'm updating the UI, I know it needs to happen here. And then this is where all the user stuff happens. And if the user wants to listen to things happening, I just need to make sure their stuff runs here. And it just queuing, the system allows it to pretty easily enqueue these things because they're just functions. So it's much better. Like CanJS 4.0 is just, it's built like, I don't know, much better. I mean, everyone is built better than the last, but this one I think we addressed some of like our real foundational things in a like an elegant and now documented way. So I'm happy with it. Actually, I take it back. What happened before is we had the batching system had a batch number. And that was like an indicator for whether you should have already been updated or not, or whether you should ignore future events. And that was just really weird. Now it's like Instead, you know all of the previous events had to have been fired if you enqueued something in the deriving task. There's no doubt. So you don't even need batch numbers anymore. That's dead. It's like I kind of polyfilled it a little bit for backwards compatibility in case people are still listening, using batch number as an indicator for like essentially when the derive queue is running. But that's just a bad way of doing things. Instead, just enter your function to run in any one of these, and then you know the previous ones have to be complete. So, it's much better. Anyways, I've talked about this a lot. So
I have one question. So you made a YouTube video about can queue, I think, and I watched it. And is there a possibility you talk about if there is you put something into the derive queue, and then there is some point where you go back to the notify queue and start again the loop. Is there a possibility to get into an infinity loop with that approach?
Yeah, of course there is. Like you could, like I could bind to first in the mutate queue here. I could bind to I could just set first again to like first.lowercase, and then like every modulus like upper or lowercase it or something like that, and you would just have an infinite loop because you're changing your you're changing your source. Now, the one thing, though, that we can prevent, though, now that's in user code. The really good thing about this is I was actually talking with someone yesterday about this. Let me just grab this source here. He was telling me that it's like, because I've scared people so much with like not using events, like the events object inside of a component, like, hey, you should all avoid this. Really, the reason is like you should use streams. But because of apparently that pressure that I was giving people were using observations and doing mutations here as like a way of, in their getters, essentially, doing mutations in their getters as a way of like, getting event-like behavior. Basically getting event-like behavior, but doing it just somewhere else that they thought, oh, this must be better because it's not in the events object, which people would set. So like, let's say I wanted to know when full name changed. Instead of people doing something like this, like view model full name or something like that, what they would just do is create a getter in their observation or in their a getter. They would just be doing stuff in their getter here and then like changing things side effectually. Like you could think of it as this was the getter. They could be like this dot view model or this dot like something just happened because first and last changed. Right? Now this is, if anybody's doing this, this is way worse than events. Please do not do this, because what happens here is this runs in the derive queue, and it even runs in that special queue in CanJS 3.0, right? These at least try to run in 3.0 in like kind of that, what would be something like the mutate queue. In 4.0, these definitely all callbacks run, like unless you purposely try to register them in a different queue, they all run in the normal queue. So one good thing that I think 4.0 will be able to do, if someone does something like this, like is abusing a observation, one thing we can do is we can check any setter, anything that has the ability to set a value. We can check what queue we're currently running in. And if you were running in any of the queues other than the mutate queue, you should either be in no queue or you should be in the mutate queue. And if you're in any other queue is running right now, then we can throw an error, I think. We shouldn't even allow people to do this kind of stuff. Or like a double, I don't know if there's like an extra level of warning that we can throw if we want to throw a warning instead of an error. People, we want people to upgrade. And if they've got code like this, of course, this is still going to do a mutation and can still work. It's just like, that's really not what you should be doing. So I don't know if that was like, I know I kind of took your question, Julian, and like answered it one way, then it had a bunch of other information I think is interesting. But yeah, you can still create cycles. There's not really a way of preventing cycles. We could see, I mean, we could say that we could track and remember all of the tasks that were entered. And then if we get to the mutate queue, if any of those tasks are re-registered, then, but they could be re-registered for different reasons. It is possible that you have like first got changed and then you listened to it and then you changed last, but then you were done because now only last changed. That's okay. You would have the same tasks registered. What you'd really want to do is actually somehow track the actual mutations. And then you would say that first has changed twice. And then if the mutate queue keeps running, and if the mutate queue tries to do anything, we see any other mutations that are the same kind of mutation, then that's a big, potentially a big problem to avoid. And we could maybe inform people of that. But sometimes, again, it might not be a problem because you could it's possible that you have mutations happening that eventually do kind of coalesce. And it's not actually causing an observation to run or something like that that breaks the cycle. So I don't know. I think it would be so valuable to give people a warning. I don't know.
So I had a question too. So most user code is going to run in the mutate queue, right? So you mentioned that it's possible that it would be running not in a queue at all. What is the scenario that would happen?
Well, I started trying to put as much as possible into a queue. Like we talked, we made event handlers run within a queue, and can't stash bindings.
Right.
There's still other entry points that obviously someone could do a set timeout or something when a promise resolves. I don't know if I made resolve. Maybe it does kick off a queue. There's just undoubtedly a few places in CanJS that are
that we just haven't put in a queue yet.
Outside of the queue, I know that can connect, if you the real-time methods update instance or something like that, or whatever the real-time methods are. I don't think those are put in a queue yet. I did put some things inside of a queue, some of the CanJS-y, can connect. I think when things return, it does put that into a queue. I feel like I did that. I don't remember because it's so nice when you turn on the queues logging to be able to I don't know. I'm using it all the time. I don't know if anybody else still has, but it's glorious. Let's see here. We're spending way too much time on this, but maybe not. Oh, this is. Yeah, so when a list gets updated, so this is this gets called when the find all comes back, right? Or when the get list comes back. So I enqueue that in the mutate queue because obviously I'm about to mutate things. And the nice thing here is, again, we provide these reasons and we also provide these names. So, and I think I made the base connection updated list, I think I name it right. Matthew was saying Matthew put something oh, this is nice in the stack trace. I did a little bit of this work in map. I'm not seeing where I did it here, but I think I made it so that this does say the name. If you provide a name to your connection or whatever, it'll call that it's the updated list. So you'll see to do connection updated list. And then if you look at the reason log, it's setting, and it'll give you the name of the list set, and it'll give you the list, and it'll give you the data that it's updated with. So you can actually now see if you do queues.log, whenever data comes back, you would actually see we're updating a list because we set the completed to-dos list was updated with this data from the server. So these big big things that happen in CanJS should all be kind of enqueued and given a reason log. And ideally, in the future, some very enterprising person or us will maybe, I would love it if there's a Chrome developer tool that like has a call stack that's like CanJS's call stack. That would be awesome. But this, we have one now. It's just kind of logged to the console. It's not as cool as the one built into a browser. Anywho, I went for way too long. Who's next?
Kevin, you want to go next?
Sure. Yeah, so the last couple weeks I've been working on the last few like edge cases for what we're doing for Stash 4.0. So some of those, like Matthew was mentioning about the automatic scope walking, that stuff's all been removed. And then the other big thing is, show my screen while I talk, is automatic function calling. So if you guys can see my screen. So this is one of those last edge cases. So in Stash 3.0, if you do something like this, where you have a click handler, and this is a function here that you can see that returns an object that has another function, this log thing, that returns an object that has another function for this. So in Stash 3.0, each of these intermediate functions, this console here, and then this log here, would be called when you click on this button. In Stash 4.0, we don't want that to happen anymore. That's not going to happen anymore. So you have to explicitly call these things. So calling console and calling log. So that's what you have to do in 4.0. But the problem was this doesn't actually work. So we were guiding people to do it this way, but these weren't working. So this is one of the things that I was working on. I want to kind of walk through a little bit of the code to talk about the changes that were necessary to make this work. So here this is can stash bindings, we have this handler function that gets called for event bindings. So that's what this is. So this is basically when you do an event binding like this on click, this is the thing that actually gets called. So what this used to do is it used to look for like this says, grab the first item and treat it as a method. So that would be this console. So there was all of this logic to kind of manually do this process of figuring out what the thing is that we need to call. So all of this was changed. So in 4.0 now we already have Stash builds up what's called expressions. So we have a function, this value function for the expression. So whatever kind of expression you're using, in this case, this is a call expression. This eventually is a call expression here. So what we're doing is we're just calling the value of this, and it's going to figure out what's going to happen here. So we got rid of all this special logic that was trying to figure out what to do, and we're just replacing it with calling the expression. So I thought that was it. I thought that was going to work, but it didn't. So just this change ended up making this infinitely loop. And the reason for that is normally if you have a call expression like this, so if you were doing something just with a magic tag and you did this, you would want this to be live bound. So if whatever you're using inside of this changes, you'd want this section to update, right? But with click handlers like this, you don't want that to be live bound. We don't want this to get called again if something changes. We only want it to happen when you click on something. So in order to make that possible, there's this option now that says do not wrap an observation that you pass to call expressions. And in call expressions, we say, if you don't want it wrapped in an observation, we're just going to call the function. If you do want it wrapped in observations, this is the old behavior. We're going to create this observable and bind it and all this stuff to actually make this live bound. Cool. So now with those two changes, clicking this, it works. Yay. Just like it used to work. Cool, that's it. That's my demo. Anybody have any questions?
Can you turn on queues logging?
Yeah, maybe. No. I'll let Matthew go or Manuel, and I'll install queues and actually turn on. We can show you what that looks like.
Which reminds me, actually, Manuel, I think, I don't know how other people feel it, but I feel like can debug automatically, if you've got it included, add can to the global namespace. Can namespace, or at least add a, what I've thought about doing is adding a proxy, or either a proxy version, or just, let's just do a big getter that loop, like, can debug can be as big as we want it to be. That's the best thing about can debug, because it's like never going to be pulled in production, so we can make that like a 100 megabyte file. Not that big, but we could even just loop, just take whatever the can object looks like if you do can.all, and just basically get that list of properties, loop through all of them, write getter setters, and just like have a warning that kind of like lets people know, like, hey, you're using, maybe it only happens once, like, hey, by the way, you're using can, you're using the can on the global namespace added by can debug. This is not here in production, so do not use this. Something like that. Anyways, I think that would be really good.
Cool, so I think I'm next. And what I'm going to talk about, something that I feel like been working for ages now, it's can debug. There used to be an old version of this package that was that exposed a single function. Now with the changes that I've made, it exposes an object. And I'm going to skip these first two functions because we are not sure how they're going to look like in the final version.
Manuel, sorry to interrupt you. Would you mind bumping up the text size of everything that you do? Your screen is massive. That's an improvement. A little bit larger would be great.
Okay. What about now?
Yeah, thank you.
Okay, cool. And yeah, I'm going to talk about the last two functions of what I change and what changes me. And basically the idea for these two functions is that we want to show, to log, how observables affect each other, and hopefully understand the user, help understand the user how the data flows through the application. So I think it will make more sense if I explain with an example. And the first one that I have in the doc is really simple. It's just a define map with a full name property that uses first and last. And we create an instance of that person constructor. And then we bind to it. We need this in order to log what changes me to work. Justin and I have talked about maybe making this automatically when you use log what changes me. But what we want to avoid is introducing side effects when you call the function. So for the time being, you will have to make sure that the property is bound. And then when we finally call the log what changes me function, it accepts two arguments. The first one is the observable, and the next one is optional, and it's a key. In this case, it's the full name string of the key of the instance. And then what that writes out, let me see if I can get the whole screenshot here. I have a live version, so I'll show you that in a minute. But basically what it shows, what it prints out is something like what you're seeing right now. And we're using console groups in here to nest the information of the observables depending on how they are related to each other. So in this case, the top level group is a full name property of a person instance. That's what we just passed to the log what changes me function. And then for each of this group, and let me actually show the screenshot below. We have three like identifiable parts for each observable: the name, the pretty name, and then we have two properties, which is the current value of the observable and the property provided. And then we have the actual reference to the observable. And this is nice because you can like click around in the console and inspect properties and internal methods. And then the third group we have is the dependencies of the observable in the blue box. So the properties, the groups that are in the green border box, we label those depending how they are related to the parent observable. And that's what I'm trying to explain here. We have like three different labels right now. We have derived dependencies, which are observables used internally by the parent observable to derive their value. And then we have mutation dependencies. It's probably harder to explain, but these are observables that set the value of the parent. And you can find stuff like that, like in can-stash bindings when you are setting bindings. There is a lot of code making observables interact with each other, and we keep track of that through mutation dependencies. And finally, we have two-way dependencies, which are both derived and mutation. And the output is recursive in the case that if we expand the derived dependencies of full name, we can see the same pattern inside for this observable full name getter. We have the blue box with the prename. We have both the value and the object reference. And then we have the dependencies of the observation. And I think that one thing that I point around in the documentation is that some of the observables you see in the output don't necessarily match the user's application code, because if we go back to the example, we only have like a person map, and with full name and first and last properties. We didn't have this observation in the user code. But as this is internally used by DoneJS, and we showed it in the output, we talk about getting like maybe a flag or a different version of the log function that hides this internal stuff, so it doesn't introduce noise for users. But we're still working on it. And then I actually want to show some of the examples that I added to CanDebug itself. And I think I'll start with a simple one, CanSimple observable. What you're seeing here is just I'm using visualization library to draw the dependency graph. And I think let me get the actual code. And I probably you need this. Okay. And the code for this one is very simple. I just have two observables holding an A and B value, and then I have an observation, which is like a compute, that is just joining those two values together. And then this coding here, the only thing that is doing is first making sure that the observation is bound, and then I'm drawing the graph. And the arrows, you can read this arrow as observation 1 is deriving. The one here is the index on which my algorithm is visiting the nodes. So basically how this reads is that the observation derives its value from these two simple observables down here.
Actually, Manuel, I think if you name that function like AB or something like that, then that observation up at the top would take that name.
Yeah, probably. I don't want to try that right now. Okay, I have like more complex examples here, and I think the other one that I would like to show is this. This is let me see. Actually, the code is the same map I showed you before, and then instead of using the map instance, what I'm doing is using stash to render an input, and it binds to the first property of the map. And you can see the dependency graph that is it starts in the HTML input value property, and then this property right here is one of the observables that I said that are internal, and it's two-way bound to the HTML input, and the arrows point to the person first, and I think that matches the actual binding direction in here. And finally, the other one that I would like to show is the crossbind. And this is a little bit crazy. Actually, I think I'm going to hide this and refresh so it's easier to see all the nodes. That didn't help, but let me try this. So we have a lot more nodes here, and this grows like really fast. And the reason we have so many observables is that we're seeing the graphs for the HTML that is bound to the first property, and also the other one that is bound to the last name property, and those two together for the heading element that actually renders the full name. Let me actually show you the code so it makes sense what I'm saying. And this would be, I think, cross. Yeah, the same exact person map that we had before, but instead of having just a single input, we have two inputs. Each of those is bound to the first and last, and then we have an H1 heading that interpolates a full name property. And that's what you're seeing in the graph, even if it's like too noisy right now. But you start here with the HTML heading element that is two-way bound to the person full name property. And then there is a getter for that full name property. And it's two-way bound to the HTML input bound to the first. And the same thing for the one that is bound to the last property. And I think that's it for me. I hope you don't have any questions.
Sharing that, Manuel. Sharing that?
Okay, sure. Let me try it again. Is it working?
I mean, I think this stuff is freaking amazing. Now, I mean, we still have a way to go, I think, to like how we present it to people. Because, you know, I think we do have to have that like clean version that removes kind of the internal mechanics of CanJS. But, you know, one thought I've been having about CanJS lately in terms of like our approach and the problem we're trying to solve is, you know, there's this pushback with like Redux architectures and immutable state and things like that, because it can be hard to understand your application if you know, you have observables and you have like, you know, spooky action at a distance kind of thing where like, hey, you have sibling communication and things like that where they can change each other. You know what else was really hard before like visualizations and it changing like how it worked happened? Multiplication. If you try to multiply with Roman numerals, or you did when you like during those times, it was like you were a freaking genius to multiply out Roman numerals. But then they like went base 10 and it's like now, you know, like what second graders can do multiplication, right? Because they have the tooling gave them of just how they write numbers, gave them the cognitive ability to understand multiplication. It's not like people were smarter, you know, just because they wrote the numbers differently. I wonder if by embracing like tooling like this, that we could say, hey, yeah, writing huge applications with observables, that was like something that was, you know, hard to wrap your head around. But by providing the tooling that, and like, then suddenly your application is much more understandable. This to me is, you know, there's a lot going on here, but in reality, you can almost look at it as like there's an HTML element and it's two-way. We could remove those, you know, if you look at 9, it's two-way bound to 6. So we could remove those two inner ones and just have like a line with double-ended line that points from 9 to 6. And then 6 points to 4 because person's first full name is on 4. And 10 and 13, you know, the last property is two-way bound to an input element. And full name is put in the page as a one-way binding. You could have an arrow basically just here's full name 4 to 1.
4 is an internal thing, right? Is it?
Or no. That's
Wait, I thought
getter.
That's the getter.
Oh, 3.
I thought 3 is the getter.
3. Sure. Yeah, we have to figure out. Yeah. So there's the observation. Why does the scope read hit that object? I think that's a no. It has to hit the observation. Okay, I get why it is the way it is. Well, does it? That might be a bug, Manuel, that we need to talk through. That might be a bug, not in your stuff, but in how. Because I have to think about that one. Anyways, but you could theoretically we can clean up the graph so then it's just like essentially full name is points to 1, 3 to 1, and 10 and 6 might point to 3 or something like that. I don't know. Does that? I think that would be really awesome. I mean, maybe not presented in a graph like this. Of course, it would be ideal if it was mixed in with the development tools. You could actually see this as part of the DOM. But you know, just as an idea, like what tooling would give people the ability to be like, okay, I understand how this observable is involved in the rest of the world. So those problems of action at a distance go away, and the benefits of kind of more simple, multiple communication channels that observables provide, because everything can be its own communication channel, you get those benefits.
How would that work though? Like how would you get this thing up? Like, would you like click on the H1 and they're in a context menu or something and say graph me and it would pull this up?
Yeah, I'm not a designer. I feel like we'd have to start like, involving them almost a little bit on how to like make it, the user experience, what it would look like. But yeah, in an ideal world, to me, I think there's two questions people want to answer is, how does this value get changed? And what if I change this value, what happens? I think that in an ideal world, like, yeah, you'd be able to like click on a value, almost an observable, and you would just say like, show me what this can change. Or conversely, how does this value get changed? And you can kind of see both sides of that graph. Maybe it's an element you can click, and then it just shows you the observables, like in where they are in the code. Ideally, you could click any one of these, and it would take you to that line of source. Like, oh, okay, where is person first? Where is that? Where is that defined? Boom, takes you to that define map property. That input element, or like at least the binding for it, the first binding. Show me where's the binding. Okay. Because it's okay. Show me the element, and then show me where the binding is set up. Right, and it just takes you to that line of code. It's like, oh, you can really understand your app and how it's put together better that way. I think that's a interesting idea. Is like, let's embrace mutations and observables, at least where they make sense. I still think streams are the better solution for certain types of transformations of data, absolutely, and streams should fit in with this. But at some point, it's nice to have your one component. People are gonna want to build, people are gonna want to build custom elements in the future that are mutable and have events and things like that. I don't know. I think as an idea, it's got a lot of promise. It's just like, how can we do it and get good enough at like the dev tools and that kind of stuff. I even thought it'd be really cool, especially with queues. What if you could like change the first and you could see how that like propagates and changes values through the dependency graph, right? Like I almost thought about a slow, like they have time travel in React. Like we could do like a slow mode queues really easy, where it's like you can see how, and especially with the graph, where it's like we slow up the queues, you can change your value, and then you can see like how every value in the graph changes, right? And we just like do one task at like human timescales. Or people could just like click, 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 and just like, they could see the task. They can see the names that are being put in the task, almost like that graph, and they can just go next, 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 next. Now, it's trickier to do undo, although we can just, of course, like restore all, like hard press in the state, just be like, we could just say like, this is the state, like of every single thing, and like we're gonna shove it all in again to get to the point we wanna be. We could do that, but to me, even to just be able to like start and say like, okay, I can see the tasks as they're registered in the UI and be like, see how data changes and flows through. I think that can really help certain debugging issues. Dream big, folks.
Yeah. Manuel, that was a great demo. Thank you for walking us through that. Matthew, do you want to go next? Yeah, 4.0.
Yes, I will. I was going to show some can element stuff, but since we're already at like an hour 40, I will not do that. I'll save that for another week. So I'll do something very simple. Development bundles have started to become somewhat popular, at least a lot of the teams I've just talked with. A lot of them are actually using development bundles, so that's cool. Kudos to Manuel, who developed this feature. There's a problem, though, is that you developed a CanJS application, and you didn't get any of like the nice console warnings that we were talking about earlier, and that's because development bundle is basically it's essentially a build, and when we do a build, we remove all the development stuff so it's not in production and all that. So anyways, simple one-line fix for development bundles. There's no reason to exclude that information. And here's an example of some code, and this would be in the output. So yes, that's all I have. Keep that one short and sweet. This is now in Steel Tools version 1.10. That is all.
Sweet. Thanks, Matthew. Does anyone have anything else to show off or discuss before we go? Nope. Cool. Then I'll announce that next week would normally be when we send out another survey and talk about what we're going to be potentially working on in the following 6 weeks. Because of where we're at in delivering what we have taken on for our previous epics and the previous surveys, we're not going to send out another survey next week. We're going to instead continue to focus on getting CanJS 4 out the door and what we had planned to take on for this epic. And then we'll run another survey in 6-7 weeks from now. Anything before we go?
I guess what is in the next, like what still is remaining?
The routing guide and
Forms guide.
Forms guide.
The can set replacement, can query.
Yep.
If there's any other big ones.
Can element.
Can element. Yeah.
This tree shaking spike, did that? Maybe that's done. I don't know.
Yep, I did that. There's an RFC in Still.js.
Okay. I'll have to read.
Yeah, so a few things that we still want to work on over the next 6 weeks after we get CanJS 4 out the door.
Yeah, and the next 6 weeks is always nobody works. So
yeah, that's another thing.
Hard to do anything else. Yeah.
Yeah, to kind of explain why, like this, we had Thanksgiving in the United States. People will take time off. We've got Christmas and New Year's in the next few weeks. So I think it makes more sense for us to work on what we want to deliver and not get further behind in trying to tackle things.
Yeah.
So
let's finish up with what's left on our plate.
Yeah, for sure.
We'll go into next year hungry.
Yeah.
Hungry for new issues and things to work on.
Yeah, for sure. All right, I think that's it for today. Everyone who's watching on YouTube, either the live stream or the video afterwards, thank you for watching. Like and subscribe, and we'll be back in 2 weeks, right before Christmas. See you guys.
Yeah, thanks, Jason.
Bye.